Hello friends, now we will see how to construct a DFA for accepting the string that starts with 101. That starts with 101 and followed by any sequence of alphabets. Here our alphabets are 0 and 1. So 101 followed by any sequence of symbols over the symbol 0 and 1. Right? Consider the string will be like this. W is equal to 101 followed by X. 101 followed by X. Here the X is replaced by 0, 1 whole star. We already know 0, 1 whole star means that is the epsilon. Either symbol 0, 1, 0, 0, 0, 1, 1, 0 and combinations in length 3, combinations in length 4. Like this the X can be replaced. For example, if X is equal to epsilon, the minimum symbol is 101. The minimum number of symbols or minimum length string accepted by this DFA is 101. If X is equal to 1, 101 followed by 1. If X is equal to 0, that is equal to 101 followed by 0. If X is equal to 0, 0, 101 followed by 0, 0. X is equal to 0, 1, 101 followed by 0, 1. Right? These are some example cases. Now, how we will construct a DFA? Here, what is the minimum string length of the string? Minimum string length is 3, 1, 0, 1. That is, we have to make transition from the start state to first intermediate state for the symbol 1, first intermediate state to second intermediate state for the symbol 0, from second intermediate state to final state for the symbol 1. Now, the DFA will be like this. That is, the start state is Q0, from Q0 to Q1 for the input symbol 1, from Q1 to Q2 for the input symbol 0, from Q2 to Q3 for the input symbol 1. Right? This is the basic structure of this DFA. 101, we are having forward transition path for the symbol 101 from the start state to the final state. Here what is our goal? 101 is the starting symbol followed by any sequence of symbols over 0, 1. Any sequence of symbols over 0, 1, that is 0, 1 whole star can be represented as a self transition for the state Q3. 0, 1 whole star can be represented by a self transition for the input symbol 0, 1 for the state Q3. Right? 101 and 0, 1 whole star, that is for representing any sequence of symbols over 0, 1. Now this is enough for a problem, that is 101 followed by any sequence of symbols. But we have to construct the transitions, that is remaining transitions for the state Q0, Q1 and Q2. What are the remaining transitions? For the state Q0, 0 transition. From the state Q1 for the input symbol 1. From the state Q2 for the input symbol 0. We have to make 3 more transitions for these 3 states. How to make the 3 transitions? First I consider from Q0, if you are having transition 0. For the symbol 0, if you are having self transition. If you are having self transition from state Q0 for the input symbol 0, means 0, 1, 0, 1. This becomes an accepted string. If you are having self transition for first 0, from the state Q0 for the input symbol 0, you are making self transition like this. You are making self transition like this means then the string 0, 1, 0, 1 will become an accepted string. But this is not an accepted string. This is not starting with 101. This is starting with 010. So the self transition for the state Q0 for the input symbol 0 is not a right one. So what we have to make transition? How to make transition for the symbol 0 from the state Q0? If you are moving in the forward direction, that is either to the state Q1 or to the state Q2, the same problem will arise. Some other string that should not start with 101 will get an accepted one. Right? So, for this type of problem, here we are introducing a state called dead state. The dead state will be named as Q4. Here we are calling the state Q4 as a dead state. That is, the transition from Q0 for the input symbol 0 is moved to this state. This will be never proceeded to the final state. Likewise, for the state Q1, we have to make transition for the symbol 1. How to make the transition? If you are moving the transition 1 in the forward direction, the string 10, the other strings that should not start with 101 will be an accepted one. So we should not proceed in the positive direction, that is in the forward direction towards the final state. If you are giving back transition, if you are giving back transition like this, if you are giving back transition to the state Q0 for the input symbol 1, what will happen? The string 1101. The string 1101, that is first one from the state Q0 to Q1, and for the second one again we are going to the state Q0. For the third 0 it is to the state Q4, and for the last one we have to make transition for the state Q4. Maybe it is having the self transition for the input symbol 0. Right, input symbol 0, it is having some self transition. Now the 1101 symbol gets dead, right, gets halt in the state Q4. Q4 is not considered as an accepted state. Maybe the transition is correct. Right, we will consider in the next case. Consider some other example string. 110 is a not accepted string. Here also the string is not accepted by this DFA. It halts in the state Q4. Right. So next, what is the remaining transition here? Q2. For the state Q2, we have to make transition for the input symbol. What symbol here? Already we are having transition for symbol 1. We have to make transition for the symbol 0. Where we have to make the transition for the symbol 0? Either to the dead state or to any states, that is back transition to the states Q1 or Q0. Right? If you are moving to the back transition to the state Q1, if you are moving to Q1, consider an example 1, 0. For the next one, we are giving back transition. Back transition means from Q2 to Q1. After that 0, 1. After that 0, 1. 1, 0, 1, 0, 1. This may be a correct accepted string. It starts with 101. After that 101, it may consist of any sequence of symbols over the string 0, 1. Right? It may be correct. Right? Otherwise, we have to make the transition to the dead state. Either we have to make back transition to avoid the forward path, that is transition towards the final state, or we have to make transition to the dead state. If you are giving transition to the dead state means this will not proceed, right? If you are giving back transition means this will proceed up to n number of symbols after this 101. So if it is possible to give back transition for that particular state for any symbol, that is the appreciable one. Here we are making back transition from the state Q2 to Q1 for the input symbol what? 0. That is first symbol is 1, second one is 0, again third one is 0. No, here the third one is 0. If you are giving the symbol as 0, after that 0, 1. This is not an accepted string. So this will not be considered. This transition will not be considered. From Q2, we have to make back transition or transition to the dead state for the input symbol 0. Dead state to for the input symbol 0, we are making transition to the dead state Q4. Right? Next, from the state Q1. From the state Q1, consider the transition again. We are making transition for 0 in the forward direction. For the input symbol 1, we are making back transition. Consider one more example. First symbol is 1. Again second symbol is 1. Again the third symbol, first symbol is 1. Again second symbol is 1. Again you are having the third symbol as 1. After that 0, 1 means this symbol is also a not accepted string. Right? 111, it is starting with the string 111. This is not accepted for the given problem. So this is also a not appropriate transition for the symbol 1. For the symbol 1 from the state Q1 is also to the dead state Q4. Right? Is also to the dead state Q4. Now this is the DFA that accepts the string that starts with 101. 101, for 101 we are moving transition in the positive direction, that is towards the final state. The remaining transition has to be considered and worked out. Based on the trial and error only we are solving this type of problems. Here we are introducing a new type of state called dead state. That is, this will not lead to a final state. This will not lead to a solution. Right? So this type of states are called as the dead state. That's all.